it reasonable to believe, though, that something else is going on without that observation? Even if we concede that that observation hasn't taken place, it can be seen from all three continents at maybe it's two at the same time. Well, actually, there is a way it can be seen from all three at the same time. But let's say just as a normal, easy observation, we could get it from two places and then a third slightly later on. We won't see it sweeping across the sky so that it could move to be in that position, or that apparent position from that continent. It will appear as it appears. It doesn't. The stars won't. We won't see those stars rise or appear from the east because we don't. That isn't what we see with polar stars. It will get dark and those stars will be in the sky and they won't be sweeping across the sky. So if it's not as described, what other explanation is there? How are the stars getting to that third continent and to be in a position where they appear to be in the south, but they're not, but they don't appear to be moving if they weren't there already?
I don't know, but I mean, if we're going to go on reasonability, then I mean, then why wouldn't we just?
If we're going to go on reasonability, we wouldn't be having this conversation at all.
Yeah, the point is, the stars can be seen in due south from all three continents. What difference does it make? What difference does it make if the observations are simultaneous? How does that change it?
Because you're saying that you could see it at the same time. That would mean that it's right there, right in the middle.
I mean, it always is right there. Even if the people in Australia aren't seeing it at the same time even if it's not right there, if it's daytime in Australia and you're in South America, when it gets dark, it's right there. It doesn't move in from Australia. It's right there.
Well, then that just would falsify the Gleason's map. So what?
It would falsify.
Does that mean that we've got that observation falsifying the AE map for your flat Earth map?
Maybe
the observation of Polaris, which is falsifying the fact that it's not flat,
which is all built into the model.
Evidence to support your postulation that the Earth is flat.
Yeah, no one's ever went around along a single line of longitude.
Evidence. That's a lack of evidence. Do you have evidence?
Yeah, it's flat because I see flat.
And can you now provide the evidence?
Yeah, go outside and look.
But it's not really.
I look and I see hills, I see clouds, I see sky, I see either a position where the Earth is in motion and the sky is still, or the sky is in motion and the Earth is still. If I know nothing else about the world, that's as far as I can get. I can't say it's flat just because I go and look at 0.01% of the Earth's surface or less.
Great, so try flying all the way around.
But again, you don't have any evidence to assert that it's flat, Jerry. That's the point I'm making. You've got nothing.
Because my unmanipulated experience tells me that it's flat.
Your unmanipulated experience, but also
you can't show any evidence for it. You can't say, it's flat because of this, which is what we've been doing. It can't be flat because of this. Sigma Octanus says that, you agreed. If that's the case, then it invalidates any form of map referencing you've got. So you can't even tell me in your world how far it is from Dallas to Santiago. You've got no map to get you there. You've got no distance allocation to get you there. Yet we know how far it is. Sorry, go on, Ron.
Not to mention your unmanipulated experience would also tell you there's no such thing as cellular life. Your unmanipulated experience would tell you that there is no separation of light, or there exists light other than UV. That was my bad, other than visible light. So your unmanipulated experience is not nearly a large enough tool set to know much about reality.
There's also this tiny hard point, Jerry, that I think we talked about this before, which is which is this. I'm sympathetic with this idea that, hey, look, I look outside, I go to the beach or whatever. My experience is that that's okay. I can be sympathetic to that, but when science or when mainstream science or model shows you that the argument is that the Earth is a certain size, and then when you look, you realize you do some calculations, you shoot geometry, and you realize, oh fuck, it looks exactly like that also. Now suddenly you're in a situation where if you're honest with yourself and if you're a rigorous thinker, you have to go, okay, well, if I'm trying if I'm trying to pick between what they're telling me and what I thought it was, well, I can't really use this tool set of way it looks anymore because both of these things will look exactly the same on that way I used to use. So, of course, that's going to cause confusion because I can't distinguish between a flat Earth and a very big Earth. So I got to come up with a different method now.
Right. You got to use the stars and then say, oh, well, look, it's the stars make a sphere. So Earth is a sphere, even though we haven't gone all the way around.
It's not really what happens, but you can use other methods if you like. But I don't think you're being very fair when you say,
No, but that's how,
like it's a trick or something. I just don't find it very reasonable. But you can use other methods if you think the stars are a trick. There's lots of ways to do it.
Okay, so what else you got?
You can use Aristophanes' method.
What, a couple of sticks?
Well, I would use more than two because that will give you an ambiguous result. But it's a lot of
right.
sticks.
But everyone brings him up, but he only used 2 sticks. So what's the problem?
Yes. Well, when I say him, I mean the one that we know will work, which is more than 2 sticks. So how about that one?
Yeah.
Well,
look at Slice Bar Case, 23 points. You mapped it out. You either have the sun in 23 different locations, none of them where it should be, or you have one large sun a large distance away on a spherical Earth. Just map it out. There's only one way things work, Jerry.
What do you think, Jerry, about that one?
I think that places on the map would match that because you're using the stars and the sun. It was made, all the latitude and longitude lines where you are was used with the sun and the stars. So of course it's going to match.
I mean, this doesn't really make sense, but okay. I mean, if you think about it, it falls apart when you think about how maps work and the fact that you know those latitude lines are a fixed distance apart. If they weren't really that fixed distance apart, doesn't your common sense tell you that this would cause a lot of problems with, say, distance calculations and maps and whatnot?
Not if you lock yourself into this one idea of what the Earth is.
I'm not really sure what that means. You can't lock yourself into an idea that violates reality and get away with it.
It's all based on the stars, and it's too hard to go all the way around or all the way to the top or bottom.
That's a different topic, but it's not too hard. And frankly, if you're honest, though, you don't need to do it, but it has been done, but it shouldn't be necessary. It's only through a lack of understanding of other methods that you would think that was necessary. But again, do you find it reasonable to imagine that you can lock yourself into a reality that is not actual reality? It's lies, like things are all wrong, and somehow not notice over long periods of time?
That's what I'm doing now.
So you can verify these measurements. You can verify these stellar observations by just going along the ground. You can verify the latitude and longitude holds tight everywhere you measure it. You can do it by walking. You can do it with a tape measure. You can do it with a transit. You can find these latitude and longitudes. And
a tape measure would be lovely. That would be lovely. Just
100 miles east.
North, go south, all the way around, and there you go.
You just have to validate the.
We have done this, Gary. We've done this a lot.
Nobody's done that.
Yes, we have.
You took a tape. Somebody took a tape measure and went north south.
Well, we use
around.
LiDAR. We use LiDAR to do it, so it's a laser tape measure.
Yeah, that's lied, and that's not acceptable because maflurfdom.
Well, here's the problem, Jerry. Is that so much has been done. And what you have is like a toolbox of excuses. None of these excuses are very fair. They're not really very. I think they're not very critical thinking. That's not an insult to you. This is more to the community. And so when I tell you something like, "Well, we've done that with LiDAR," you're going to say something about, I don't know. You're going to tell me space is impossible or something silly. So you're going to tell me something, space is impossible. Now, this is an excuse you pull out of a toolbox. The truth is,
could be a dome.
Say again.
there could be a dome that it's bouncing off.
Sure, it could be. But the truth is that if we're being reasonable and honest, it's pretty hard to think that that's an equal claim to the evidence in favor of all this stuff happened, right? I mean, you have to kind of cling to an excuse like that.
No, I'm not going to cling to an excuse. I'm just going to say let's do it. Go all the way around.
Jerry,
When I say we've done it,
Jerry,
and
you
I
had
show
to-
you the footage from the shuttle missions, what do you say?
I say I don't buy it.
Well, that's what I'm saying. That's the clinging to the excuse of or it's not a real position. But so everything that happens, there's just you just reach in the toolbox and bring out a new. Basically,
Well, I could bring up stuff that you guys can't explain either without appealing to something, I don't know, some nonsense, like the food, because the tides don't match all over the earth, and the solar analemma. Oh, the earth is tilting. It's like, how do you know? It's like,
well, we have all kinds of ways of
We
knowing
observe
this.
something called the precession of the equinoxes, Jerry. This is something that even the ancients knew about. People going back, 2,000-3,000 years, even further. We have evidence of this knowledge, and this is where the equinox, the constellation behind the equinox changes. So we know that there is a wobble because we know that the Earth is rotating because we have other evidence to support that.
how do you know that?
How it can happen? Because we've measured it and we've observed it.
I'm going to say one more thing and then I got to go. But let me just say one quick thing, Jerry. And this is not necessarily to you, but to you. But the thing that never happens, that I always wish would happen, and I say this because I bet you haven't done it either. I always wish that someone like in your position would just deep dive on one of these questions on their own and find out for themselves exactly what all has been done to, say, determine the wobble. Because if you've done science for any length of time, you had to have done this. And whenever I do a deep dive on any question that we've answered with science, right, I am always blown out of my shoes by how much there is and how rigorous it is and how much data there is. And then when you do that enough and you just see how much work has been put in, I mean, how many different men over how many dozens and dozens or even hundreds of years sometimes, how much data is accumulated, how it all works. And then you start to get an intuition about how absurd it is to imagine that it's all just sort of hand-waved, because there's just so much of it, and it's so solid and it's so compelling. It's very convincing. And I just wish once that you take something like, how do we know the distance to the sun, for example, and really look at like the actual papers and the work done and all the data gotten and just see how much of it there is.
Right, but when I cite, experts who say that, the distances to the stars aren't like we're within 0.1%.
Yeah.
I get told, well, does that person believe that the Earth is flat? It's like, so what's the point?
No, but that's fine. If that's correct, you've got a good point to make. But that's 0.1% is pretty close for some stars. I mean, it depends on which star we're talking about, right? We're closer than that on the sun, of course, but whatever.
We're pretty good for the distance to, say, Barnard Star or Betelgeuse or any of the other stars very close to us, Alpha Centauri. We got those because we can do those through direct parallax observations. You're right.
I think that should comfort anybody who worries about science, because that's science being honest about, hey, we can't tell you exactly. We're not. We cannot tell you that we know for sure it's perfect, but we can get pretty darn close. Here's how close we can get.
And the whole stars thing is another thing. It's like, why do they stay the same if we're swirling all over the universe?
So far away.
Horseshit.
No, they're so far away, man.
How do you know that they're far away?
It stays in the same position when you drive your car past it.
You did not measure it.
And Jerry, you have to remember,
we've
been tracking it for a long time. That's why we have sailors' almanacs and nautical almanacs that have been showing the adjustments of stars over time. And we find that over time that they do shift relative to each other, such as Barnard's star. And we've actually seen a little bit of a shift in the orientation of some of the other constellations as well, going back to some of the historical almanacs. We've been watching both the proper motion of stars and the relative motion as our axis processes.
And those people you cited at 0.1%, those people, those numbers that you were citing, saying, hey, we're only within 0.1%. If you use the 0.1% error of that number, that's exactly makes sense for what we see, because that number is so big, even with the 0.1 error, it's still going to be so far away. It's like a mountain in the distance. And it's gotten to the point now that if we find an ancient cave was found in China recently that had a star, a constellation chart sort of scrawled on the wall. They're able to now figure out when that cave was active, because we have a good sense of what the sky, how it's been changing. Because when you look at their constellation on the wall of the cave, it doesn't look like our sky because it was from 4,000 years ago. And so they're able to be like, okay, this, they figure out how the stars would have changed, and then they say, this is what year this was drawn in.
Also, that 1% is not regarding the stars that we use for navigation. That's 0.1% on the ones that we have distant observations on. There's ones that are closer. We're much more confident the closer we get to Earth.
Well, what if the Earth's a 25,000-mile system?
It is a 25,000 miles.
That's what I'm saying. Is it 24,901 because that's what the stars say, or because that's what a measuring tape says?
What airlines say, it's what stars say, it's what surveying says, it's what everything coalesces on.
That all have the numbers built in, the radius and the star angles and all that.
It's such a claim to make, and it just isn't true. I don't know.
They do.
What makes you think
Jerry,
it's true?
you are approaching it in this incorrect manner of trying to think that the models make the observations. It's the other way around. The observations are what is used to build the model.
I don't disagree, but if you haven't been all the way around, you can't say that that's all there is.
We have been all the way around the world many, many times.
Across the surface of a 25,000-mile radius.
If you haven't been, can't say that isn't either.
So what's been mapped is the stars have been mapped, the solar system.
Everything's been mapped. What's been mapped.
Right? A 25,000-mile area has been mapped.
I mean, we've got mapping on Earth. We've got mapping on Earth.
We don't know
now
what's
to the level
outside of
that
that.
we can actually see the drift of the continents. We can measure it. That's how accurate we got
inside the perimeter.
the measurements on the surface of
We
the Earth.
orbit the Earth. We literally go around and around and around it all the time.
Our world is, we're viewing it and experiencing it from inside the Earth, all of us.
No, we're on top.
So we're inside that area of the 25,000 mile.
Yeah. But even being on
it's
top,
just
you can
square.
know whether or not it's a sphere because you can know if it connects up or not.
It's just a square with a dome, rotating dome around it. 25.
If that were true, then we'd have different observations than we do.
Why?
Oh, because geometry would dictate that there have to be different observations.
There's this weird idea that you have to go high to see the curvature.
That's the expected idea, not the weird idea.
And at a certain height, you just all of a sudden can see it. It looks flat like everywhere.
Gradually,
At one point, gradually, it starts to curve. Or it's just been reverse engineered. It's all about the movement of the stars and the sun.
There's no way to reverse engineer that.
You can. One day is 24 hours.
You could say it like that, but if you tried to do it, you'd find it to be impossible.
Reverse engineer it to be flat, Merle. Then start giving us evidence of flat.
That's what I'm saying. So one day is 24 hours. So the sun traveling at 1,000 miles an hour.
It violates all of our observations. We can show you a bunch of observations where that wouldn't be possible.
Why?
Like, for example, how sunset works.
Yeah, the sun comes low into the atmosphere and reacts with it.
So when the sun sets, we could trust our eyes then. But when the horizon is too far, we can't trust our eyes.
I'm not saying trust your eyes. I'm saying do everything you can to figure out how the sun sets, and it belies the idea that it's moving at 1,000 miles an hour.
Actually, we want to use special equipment. We want to use a solar filter, so we get rid of the glare of the sun, and we can
It makes
see an
sense.
object. So we need to enhance our sensors for that as well, Jerry.
It makes
So,
sense
you
it's
know,
traveling at
this is
1,000 miles
part
an
of
hour.
using good instrumentation to take measurements, to take observations.
When we always see flat water, it's like, oh, no, no, no. If you get really far away, then it starts to curve. So it's like, trust your eyes when you see the sunset, but not when you see flat water.
You can measure it at
So
like
it's
500.
flat water. You know, I mean, even in the glass, you still got that curve. It's still bowed. When we look at the sea, it's always in movement, so it's never still, so it's never flat. And when we actually measure it, which I've provided observations of that in the past, we use something that's a guide to see if it is flat. And what we actually observe, no, it's curving.
So do you understand how a three-dimensional drop would actually translate into a two-dimensional perspective?
No. Let's have a look.
Okay, to understand this, you would take an object that is at the horizon over on the left side, and then one that's on the horizon over at the right side, and connect those two with a line. And in the perpendicular to the center, the actual point at the far horizon in the center will be further than that line connecting those two. It translates as actually being closer in effect. If you need, just draw a circle, take 2 points, draw the chord in between them, and you'll see that the farther part of the circle is actually further than that chord from the center.
And what does that mean?
That's why your observations of the horizon being flat are not clearly indicative of it being on the three-dimensional perspective. It's only in the two-dimensional perspective, and that's why it appears flat, even though there is the third-dimensional drop there.
So when photos like Lake Pontchartrain, we're supposed to believe that after 16 miles, there's this hump of water. Right?
Actually, that's incorrect to try and describe it as a hump of water,
I know.
because that's not what's described by curvature. Curvature is it's curving the entire distance. Hump is just, oh, there's this bump in the middle, and then it flattens out eventually. And that's not really what's observed, because of that perspective of two-dimensionally looking at the horizon, a flat line, that's a two-dimensional perspective, but you don't see that it's actually curving the same way that you don't actually distinguish between the chord connecting those 2 points on the left and right of the horizon being closer than the center point perpendicular further out.
When you say drop, what do you mean?
That's why you don't actually distinguish it when you're looking at the horizon and it is observed as being flat.
When you say drop, from what? From the horizon? The Earth is dipping. As soon as you see the horizon, beyond that, the Earth is dropping away, down, right?
At your feet.
In context, I'm actually describing, you would actually draw a perpendicular at the center point of the horizon, and you would see that there's a difference from that line that's tangential to any other point along the horizon. But because it's two-dimensional, your perspective of it, it's masked and you don't clearly see it. That's where your actual three-dimensional drop is masked in the two-dimensional perspective.
So that's the optical part of it. The physical part is that exponentially that curve would grow, get bigger underneath the horizon, be dropping away. How does the water not flow? Like because it's dropping down. Like that would cause a waterfall.
That's correct to say that, but does that happen?
Well, we wonder why it doesn't happen.
Yes, and the explanation that it's, or the actual description of it being a globe covers that, whereas the explanation for it being a flat Earth does not.
So gravity would explain that, but a contained
No, you don't
perimeter.
even have to try and run away to that misconstrued and misunderstood concept that you have of gravity. You can just state simply the observation that there isn't a huge waterfall actually is correctly described under the globe and is not actually described under the flat Earth.
Oh, good point.
I do find it interesting because, I mean, you know, obviously we're all here being advocates of you know, what we believe to be, and I think we have good evidence and good reason to hold, is an accurate explanation of our planet. And I don't see why, you know why we have the views on water and the way it acts. Forces are acting upon it, and the water is comporting to those forces. All good. So just the fact you're asking about is there a waterfall because there's a drop, it just shows that you haven't even bothered to get the basic understanding of what we're arguing for.
No, you can't. You have an excuse and an explanation. You can't demonstrate to me how an ocean can defy physics and then get all
That's
the
whole point.
it will drop. Let me finish. It drops. It drops and extends, and there's the ocean. It would be forming a waterfall. No one in human history has sailed over the curve.
Not according to the
said,
model.
Look, we're sailing over the curve. That's never been said over a loudspeaker on a ship because there is no curve. There is no curve.
How does it defy physics?
Yeah, how?
So how could you stop an
No, that's
ocean?
a question. I want you to explain how it defies physics, Mel.
I'm showing you. What force could stop an ocean?
How is it defying physics, Mel? You're asking me a question.
You have a shoreline. You have a shoreline with water, sand, water. Off in the distance, that land mass will start to drop and then exponentially grow into a sphere.
So
which means the water would have to be flowing down.
No, it doesn't mean that. That's not what down is.
That is the down.
No, you still don't understand the difference between
if you want to form a sphere, the only way is down.
Down means towards the center of the sphere, though, right?
From wherever you're standing.
Yeah, so there you go. So over there where you're pointing at, down does not mean away where you're describing. Down means towards the center of the sphere.
No, it extends, and then you have to make the sphere from wherever you are.
Wherever you're standing, down is going to be straight to the center. So wherever you're standing, things are going to be pulled into the ground, not falling off anything, but down towards the center.
So how does the water flow down all the way around the sphere and then come all the way back?
It doesn't flow down around the sphere. Down is towards the center of the sphere.
I think if anyone is defining the model of physics that we have, Merle, it's you.
No, you can't.
You're
not answering the question.
I am telling you that your idea of down
you haven't, one second,
fundamentally not
you
down.
haven't fundamentally addressed my point is, what part of physics is it defying?
When you have a hill and you have water at the top of the hill, it will flow to the bottom of the hill. That's no different on a sphere.
No, except the hill is a change in elevation where a level surface isn't a change in elevation.
So what's drop?
Drop is something that you guys want to invent, so you have to do a physical line out to show the drop physically over a distance you can't get an object to be straight enough to do it on. So it's a great excuse for you actually not to have to look at the real evidence and have a decent argument for it.
How can there not be drop?
Down?
There cannot be. How can there not be a drop?
What are you
Because
talking
we're talking
about?
about the
out
surface of
beyond the
Earth.
horizon. How can it be that the Earth isn't dropping away beneath your feet into a sphere?
That's not the direction of down.
It has to be.
No, it doesn't.
It can't be above.
What are you talking about? Down is towards the center.
It has to be under your feet.
Down is towards the center, Merle.
Under your
Always.
feet, directly straight
Under
down
your
under your
feet.
feet. And if the
Extend
Earth is curved,
to the
Merle,
horizon,
if
and then
the
it's
Earth is
dipping
curved,
away
Merle,
after that.
In the horizon, it's towards the center also. That's a different direction, though, isn't it?
And it dips
Sorry,
down
sorry,
behind
sorry
that.
sorry to butt in, but can I get some clarification off Merle? You're in Queensland, Merle. I'm in Victoria. If you were to drop a pencil, could I say that's dropping away from me? Is that how you interpret it?
No.
Right.
It's
So
beyond the horizon. So
what do you mean?
You're in Melbourne looking over Port Phillip Bay. I'm here looking out over the surfers, right? So we're both on the shore. We look out to the horizon. Beyond the horizon, that's where it starts to dip and drop and turn into a sphere exponentially. That's
This is
what they
dumb.
say.
No, but you're
That's
just
what they say.
you're being dumb on purpose at this point. Come on.
It's not being dumb. That's what the
Well, I
fucking
told you. What I
model
told you.
says.
Down is towards the center, so you know that's not what you're describing right there. That's describing some totally different situation of down. So you were describing not the model.
So am I incorrect in saying that
Yes.
beyond the horizon, the water and the land is not dipping down below the horizon? It's just extending because it's a stationary flat plane.
No, what it does is it's a
No.
sphere. The concept of down is related to elevation, and it's pointing down, always points towards the center. So that means that down's vector is going to constantly change as you walk around the sphere. That means that the surface of the sphere is going to curve at whatever that vector difference is. And it means that when you look out at something far away, you can't keep the same down that you have for it. The down over there in the distance is slightly different than the one that you have where you're standing.
When we compare downs, we find out they are different.
He's talking mumbo jumbo now. Got him.
Well, I don't think that's mumbo jumbo. I think that's pretty clear. But I honestly think that if you aren't purposely being dumb, then you're just being dumb. I don't know what to tell you. It's not that hard. Down
I caught
changes
you out.
based on where you're standing.
You said word salad. You didn't.
I don't
say
think it's
anything.
word salad. I don't know why you don't understand it. I mean, I can look. If somebody doesn't understand calculus, I'm sure it sounds like word salad. If you don't understand basic concept of down, maybe it sounds like word salad to you. But I promise you, most people in the world would not find that to be word salad.
Well, how does if you were, say, like there was an avalanche, right, and you were standing at the bottom and the big snowballs coming at you, and you're standing like with your arms out,
Yeah,
you're not going to stop it, right?
I'm going to be a
It's
snow
gonna be too
angel.
powerful.
I'll make a snow angel, and the snow angel's magic will stop it.
Well, when that water starts coming at you, do you think
What
gravity, like
What water? What
the
water?
ocean, the
The tidal
ocean,
wave that's coming.
is the huge waterfall?
What huge waterfall? I don't see one.
Well, like, have you ever seen like a sphere like
No.
with water all around it? Have you ever
I've
seen?
never seen a
that?
waterfall.
Never seen that. Have you?
Have you ever seen a waterfall?
I've seen a waterfall. Fucking
Oh,
oath.
you have not. Prove it.
Niagara.
Prove
What's
it.
funny is that Merle hasn't ever heard any of this before. I mean, this is all new information.
I know
It's just
that
so
tell by
pointless.
his staggered incredulity at how could this be the case,
Yeah.
and this is why I think he's a Poe.
Well, of course he's a Poe. Of course he is. Yes, but it's what I can't get my head wrapped around is not so much is he a Poe. That's obvious. Why? What is fun for him about pretending to be dumb every day?
He's trying to open us up to enlightenment, Scott. That's what I think the secret is. And by going through these really stupid questions in a Socratic way and never actually backing up a fucking word he says, that this is
Like
gonna
yesterday,
somehow open up
weird.
our
when I
minds.
showed you that the car in space is ridiculous. Yeah.
No, you
It's not
didn't.
ridiculous.
You
Thanks
made
for
a lot
forgetting
of claims, and
Thanks for
again, you
forgetting
still
about that.
haven't proved that was videoed in that warehouse. You have no
There's like-
evidence for it. It's a claim
like
without
20 cars in
any,
space,
without
dude.
any information behind it.
Cars in
It's
space.
sad.
You know what's
man. I think
ridiculous
that was
is
a
waterfalls.
rebuttal.
I want to see evidence of waterfalls from
In space.
anywhere. Just show me one waterfall ever existed. I mean, how about making up random stuff like what the fuck is a waterfall?
Even Moyock knows. He was out on the water the other day.
The
In a
waterfall?
boat. Yeah.
Okay, let's see a picture.
My mic work?
Yeah, you sound good now. You were sounding just like a bee. No, just static.
Before. Not now.
Hey, Merle, if you're going to cite my information, everything I saw indicated a globe to me.
Bullshit, you silly man.
I saw bridges that were going underwater. I saw boats going over, or the ground covering up boats.
Stick on point. Did you see a waterfall?
No waterfalls.
No waterfalls.
Exactly. I
Oh,
win.
fuck. No, you made a claim there and your man let you down. He didn't see a waterfall.
Yep. Exactly. And a
No, you
cross-section
claimed that
map
he did.
shows you how it
claimed
works.
That he did.
Oh,
And he
cross-section
didn't.
maps. Check it out.
You need an orthopedic view.
Listen, if you look at cross-section maps, it makes a lot of sense.
I'm sure if you had an orthopedic view, it would help.
You just cut the world in half.
It's all about posture, mate.
Look at it side on.
Yes, he could, Scott.
Yeah, that's a good point, actually. I will catch everybody later. This is an exercise in pointlessness. But thanks, Mark. Appreciate it. You need better arguments, mate. Much better arguments.
Yeah, you need a globe.
Fortunately, we have an oblate spheroid, which is close enough. So that's all good. But have fun.
See you in space. And that's how it's done.
Another 2 bites the dust, Emil.
Yep. I bored them to tears. Take the little wins.
Good on you, Will. It wasn't a debate, though, Spurs. Was it? Or was it?
No, well, I mean, that's how they labelled it.
Yeah, okay. You have to put a caveat in there, mate.
Yeah, because I remember somebody by the name of Spur saying earlier that it wasn't a debate.
Yeah, I know, but that's just how they labelled it. Bill, how about you getting in on one of those debates? Would you be up for it?
Yeah. I think I really enjoyed the time we did it.
Yeah.
But you know, it's all like you say. It's if it's a real conversation, then it can be interesting, and you're challenging each other's points, and it's good.
Yeah. Because not many people are doing it nowadays.
I don't think
last
people
standing.
I just don't think that many people care or know.
Oh, they do, Mel. Don't believe that. They do care. This is why the backlash is so ferocious. There's a huge effort, Mel. Look at the effort to hide this. They think, oh, well, we can bring it out and then put it away back under the carpet. Now, obviously, if we weren't debating it, then yes, it would be swept under the carpet, but you can see that we are exposing it daily, right?
Emo? This huge effort you're talking about seems to revolve around maybe 20 or 30 people on the Globe side who come in here day in, day out and mess with you guys. Outside of that, there doesn't seem to be a whole lot of effort.
Oh, that's what I was talking. I was only talking about outside of here, not inside, not in here. Outside of here, there's a tremendous. I mean, just look at that Richard Branson Galaxy. That is a tremendous. That's billions. They've spent billions, yes, to deceive you. to promote this this lie here. So that's what we're
To
looking
answer
at
your
here.
question
The
of
effort,
yes, no,
the effort
they
to
didn't.
spend billions and billions just so little old Moyuk still believes on a ball. That is a huge effort, Moyuk. A huge
That
effort.
predates the flat Earth argument.
Yeah, you know
There
why
were,
it's so. You know why there's such a little effort going on, is because it's because you teach this stuff to children, and then by the time they get older, they've accepted all these metaphysics of gases existing in vacuums and all that. So when someone comes along and says, "Hey, that's not possible," they say, "Oh, sure it is. My metaphysics tell me so."
Isn't it a logical conclusion if gas has weight, which it does, we've measured it, you can measure it, that it would tend towards down?
Only with a container. Only in a container.
Wait, why only in container? Why doesn't it happen naturally in the atmosphere?
There's nothing for it to press off to give you the weight.
You're
So
saying
weight
that
is dependent upon pressing off of something?
You need a surface for
How-
pressure, yeah.
Yeah.
Surfaces.
what do I push off to make my scale go down, show weight?
Hey?
What do I push off to make my scale show weight?
You're creating the force. So you need a force or a container.
And so does air.
Oh, there's no container with the air there, right?
I create the force, and I have nothing to push off of. Air has nothing to push off of, and still has weight. Even in your stupid little what do you call it?
What are you talking about, Moy?
Buoyancy argument.
You're
it
saying
still works.
you said air has weight. We know that. Yes, that's because you put it in a container.
I put it on a scale without a container walls.
Oh,
Just
you
pour
can, go on and how?
It's done with CO2.
Go on, explain to me.
Take it, you pour it down. The scale registers weight.
Pour it. So you're gonna pour it from the container, from the cup. A cup. Yeah, like. So you got the surface of the cup and the surface
If
of
you
the scale.
want, I can do it through a chemical reaction, so it's not in a cup. I could do it on. I could put it on the scale or above the scale and have the CO2 pour on.
Why
the scale.
don't we get you and Merle to debate on one of these platforms? That would be good.
Because I don't wish to talk to Merle on a platform. I'm having fun here.
You do speak to Merle.
I'm having fun here.
Yeah, I know. I'm just saying you could, for one night, get on a debate with Merle here on another live platform.
I'm here on my own terms.
Okay, that's good.
So how do you address that air has weight, irregardless of whether it's in a container or not?
Oh yeah, the air. How are you going to weigh it without the container?
Well, you're saying now that because the actual question was somehow that it doesn't have weight once it's outside the container.
How are you going to weigh it outside the container?
You weigh it when it's in the container. However,
Mm-hmm.
what are you stipulating that it somehow doesn't magically have weight once it's outside?
How are you going to weigh it outside?
You know it has weight by the fact that you weighed it. And that somehow you're trying to present it as though once it's outside the container, it doesn't have weight. So go ahead and please explain that.
It becomes weightless.
So air is weightless once it's outside the container.
Yes. You need the surface to weigh it. Surfaces.
That's not what's observed because air just doesn't magically fly off all of a sudden.
Container. How much it weighs?
Air does not just magically fly off.
How much does
once
it weigh
it's outside
of
the container? Well, it's presented as though it would weigh the same as when it's in the container. Is there something to present that as not being correct?
Yeah, because it's not applied any pressure there once it's outside.
That's incorrect. There's still observations of it applying pressure.
What, outside?
That's correct.
Where does the acceleration come?
That's not what's actually being addressed. So you have nothing to try and forward this notion that it's weightless or it doesn't have weight once it's outside the container.
Well, it's got to have an acceleration to give us this weight, this pressure.
That would be probably the same acceleration it has when it's inside the container. So,
container.
unless you're saying that it somehow doesn't.
You're saying we live in a container?
No, not saying
No?
that. I'm addressing this your notion that it has to be dependent upon a container is incorrect.
Well, that's what I'm trying to find out now. It's weightless outside. You're saying it's not. So how are you going to weigh it?
Wait. How do you establish it being weightless outside a container?
Because what's he going to press on? Get the weight.
Well, that doesn't mean that it's weightless. How do you establish that it's weightless once it's outside the container?
Told you. Now we're going around in a circle.
No, you haven't told. You've just tried to deflect away to trying to get back to the condition of inside the container. But it's being addressed about outside the container.
Get the weight. The weight comes from the container. The pressure comes from the container.
How do you stipulate that the weight comes from the container?
Because without it, there is no pressure.
So really, because there's actual observations of different gases inside the same container having different weights, that negates your presentation that it's dependent on the container.
In a container. Not arguing that. Everything in the container can be weighed, measured, calculated, everything you need to do. Got the walls. Outside, how are you going to do that? Got no wall, got no gravity. What are you going to do? Guess?
There's nothing to stipulate or suggest that it miraculously doesn't have weight all of a sudden once it's outside the container.
How are you going to weigh it?
You don't have to because you already weighed it. You know it's a characteristic of it.
That's from the container.
No, it's not from the container.
Where did the acceleration come from?
It's the same acceleration.
From where?
Inside or outside the container, it's reasonable that it's the same acceleration. Nope, it's not dependent upon the container. It's the same acceleration, isn't it, Chemo?
Where does it come from? We know inside the container it comes from the walls.
That's not correct. It doesn't come from the walls of the container.
Where does it come from?
This is actually validated by observations of having the same container that's used to contain different gases having different weights.
No, I'm talking about in the container. Where does the acceleration come from? You said not the walls. Then where?
Based upon the observation as previously presented, it means it's not from the container as you are suggesting.
Where's it from then?
Not the container, correct?
Okay, not the container, but so then where?
Okay, so now you don't need a container to have weight.
So then where does it get its acceleration from?
Well, why don't you explain or offer a suggestion?
I'm from don't know. We know it has acceleration.
You're making a claim that you can weigh the gas outside, so you must know where the...
No, that's incorrect.
You can't weigh the gas outside the container.
That's not what I stated either. I stated that it's actually irrelevant as there's no actual evidence or proof or anything to present that it is.
Is what?
That it is dependent upon the container.
That's what I'm asking you. Where does the acceleration come from?
Well, where do you think it comes from?
Container.
That's already been shown not to be correct. So try again.
From?
I've already presented the question to you. You answer it.
The container.
That's already been shown to be incorrect.
What is the answer then?
How does the container give it acceleration?
Well, he's just said it's not the container. What is the answer then? Not the container.
It has acceleration to actually be a component of the weight.
Yeah. Where does that acceleration come from?
Observe it.
Well, it's already been demonstrated, not the container, as you previously incorrectly concluded.
Well, that's what you said. I'm agreeing with you for now until we get another answer. What is the other
No,
answer?
don't agree with me. Go ahead and actually present some observation and an explanation that also explains that there's observations that it isn't from the container.
Privacy cats. Without the container, there is no pressure.
That's a wild claim. How do you actually establish that as being correct?
That's what we're taught. What were you taught?
No, that's not what people are taught.
What were you
That's
taught?
actually what people are
Well, here in England,
misconstrued
he's a
and
teacher in
misinterpreted
England,
to.
and he says without the container there is no pressure. Now, what do they teach you in America? It might be a bit different.
What contains the pressure?
You are confusing gas pressure and atmospheric again. Once again, chemo, you conflating the two, and they're
Well,
very
hold on.
different.
Cowbells is saying that it's not a container, so what is it then?
No, I'm not
Well,
saying that. I'm
atmospheric
pointing
pressure.
out observations that it is not.
You are
What?
conflating once
It's not
again
a
chemo
container,
as
so
normal.
if it's not a
As
container,
normal
what is it?
chemo. As normal chemo, you are conflating gas pressure with atmospheric pressure. They're similar but different
We didn't
causes for
talk
the
about.
same
We're
thing.
talking about the air, where
The
the
air
acceleration comes
that
from.
has mass that is accelerated toward the Earth by a force called gravity.
Okay, cowbells. Where does
Newtonian or Einsteinian?
Doesn't matter, same thing.
Where does the acceleration come from, cowbells?
Gravity.
Cowbells, you still here?
Gravity.
Do you know what gravity actually describes?
No. What does it describe?
Okay, very
Yes, he
simply
knows.
and concisely, it is mass attracting mass. That's it.
Okay, do you have any evidence for that?
You
what's on
have
your
evidence
fast chair right
anytime
now?
that something falls down. Anytime you trip
I don't
and
know.
fumble and fall down, that is a demonstration of gravity.
It
What's
depends
on
on the
your
medium
fat
of
ass
it,
chair
right?
right now,
Chemo,
Chemo?
we did
What's on your
pick
big
up
fat
a
ass
pen.
chair?
Yeah, pick up a pen and then let it go, and then you do demonstration of gravity.
Well, what medium are we in?
Doesn't matter.
Doesn't matter what
Are
the
you
medium
saying-
is.
Because that's
atmosphere
what
which you're
fit it
talking
in.
about.
Are you saying gravity's the container?
Yes, sort of.
Gravity is what contains. It is not a container. It is what contains.
How do we?
So an invisible force
Not
holds
invisible.
the
Yeah,
air
invisible
pressure in.
force. You know, like electromagnetism, like all other forces are invisible. You know.
Rated force.
You know, forces are pretty damn invisible. You know,
There's
so.
an invisible force containing all the gases.
Yeah, you know,
around
like I
it.
said, all forces are invisible usually. I mean, you tell me a visible force and I'll listen to you, but no. So to say that
Yeah,
gravity is invisible is very condescending of you.
Yeah, hey Merle, can you see magnetism, or can you see the effects of magnetism?
No.
No,
Yeah,
what?
so don't talk about invisible forces, you moron.
Yeah, this is
I
the
don't
straw
wanna-
man.
I don't wanna
Cabell
derail-
said
I don't-
that the
I don't
air
wanna
has
derail
weight,
it.
and we're just trying to figure out where the acceleration comes from to give it that weight.
Mass attracts mass. The more mass you have, the stronger the force of gravity.
Yeah, no, your opinion, Paige Shell. I'm just
No, it's
wondering
not an
what Cabell's
opinion.
opinion is.
This is not a fucking opinion. This is scientific facts, Chemo.
Again, I'm just trying to figure out what Cabell, because he's the one that said without the container we can still have pressure, acceleration,
correct.
weight.
Because of gravity. Mass,
So how do you
air
have
has
acceleration,
mass.
pressure, and weight without the container, Cabells?
As already previously demonstrated, it is that you still have weight outside the container.
Where does that weight get its acceleration from?
Weight it comes from what is already described as mass.
Where does it
Mass
get
attracting mass.
its acceleration from?
The mass attracting mass.
Okay. So what experiment do you have to back that up?
Cavendish.
When you trip and fall, you are falling just like you're falling in this discussion here. That is a demonstration, an experiment of actual gravity.
Well, that would depend on the medium. Which medium are we in?
No,
it
that's
doesn't. Gravity does
independent of
not
the
depend
medium.
on the medium.
The medium does influence the overall culmination of the movement, but it is not dependent upon the medium.
I'm asking which medium are you in when you describe these things?
Doesn't matter, Chemo. Gravity is medium independent.
We demonstrated that in air, in vacuum, you still have the same force.
Cabals, come on, you keep making these claims. Now they're over talking.
Nope, they're not claims. They're facts.
So which medium you're saying do I fall over in like this manner?
It doesn't matter, Chemo. You could be in a fucking vacuum and you would still fall.
What's the name of the medium where this happens?
It doesn't matter. Stop with this fucking medium bullshit.
There's observations of, here I'll present 2 different mediums where there's this same observed phenomenon, water and air. It happens in both.
You tested things in mercury.
I've seen other people test the same thing in mercury, and it occurs there too.
What happens in mercury? Things go down?
If they're denser than mercury,
Things go down in mercury. How about
Yes, some things do go down in mercury.
Some things go down, but not all things. Why is that?
buoyancy, Chemo. Shut the fuck up. You know about buoyancy. You're just sea lining once again.
Yeah, but as you're making these claims, you're not backing them up.
Nope, I'm not making claims. I'm pointing out facts. And it's just like he said, that that's actually the buoyant force, that actually some things float in mercury. Just like some things float in water, some things float in air, but other things actually fall down.
But not all things, right?
Everything falls in a vacuum.
That is actually correct.
So if not all things fall down, what's your argument?
Gravity still exists, Chemo. The buoyancy force requires gravity. Look it up. Stop being you've been told this at least 1,000 times each, and you still go back to the same old fucking script.
I
don't engage in an argument, Chemo.
Don't you ever get tired of the script,
facts,
Chemo?
which is
Chemo,
why you are falling down.
Chemo, do you ever get tired of the script that you're on? I mean, you say the same thing time after time after time, and so sort of like you're fact immune. You're immune to facts.
How can we know these are the facts without an experiment?
You can take observation, because an observation is not an experiment.
So how do we verify these things then without an experiment?
Cavendish experiment.
Gee, it's like I just stated it.
So by looking, it's just observations.
Cavendish experiment.
Looking is one way. It's not the only way, but it is one way to take an observation.
Okay, so where is your scientific experiment for...
Excuse you, we're not going to that nonsense either. As just described, you can take an observation of this phenomenon.
Yes, and we can see that some things fall, some things rise, depending on the medium.
Doesn't depend on the medium, Chemo. Stop this bullshit. You know it doesn't.
Oh, yeah.
On the medium.
Gas moves in all directions. They're cabals.
What's that got to do with shit, Chemo?
Hey, Chemo, why? I have a question.
Well, hold on.
Why
I'm trying to clear up. Have you finished? You conceding, cabals, yeah?
You made a claim that gas moves in all directions.
Yeah, if I spray gas from a spray can, it will go in all directions. Have you never done that before?
Are you purposely actually leaving off the rest of that? Or are you just dumb?
Well, what else is there?
I'd go with dumb.
Oh, you're probably just sea-lining again, because you actually do know that there's a overall downward bias. It does go in all directions with a downward bias locally here on Earth.
But that's what we're trying to find out, if there are any scientific experiments to back up
Cavendish, Chemo.
You don't need an experiment. You can do it with an observation, such as the spray can, and see that it does settle down.
Well, that would depend on the temperature.
It is not distinctly dependent on the temperature. The temperature can influence it, but it is not dependent upon temperature.
It's solely dependent on temperature.
Why is temperature important, Chemo?
What else is it dependent on if it's...
Does your experiment show that, Chemo?
Other than temperature, cabals, what else does it depend on?
What are you talking about, Chemo? There's temperature. What's temperature got to do with gravity?
Cabals, if it's cold, it goes down.
Chemo, ask the question. What does temperature have to do with gravity?
If gases are warm, what will make those warm gases sink or go down? What else?
It's called gravity, Chemo.
Did you hear his answer, Chemo, or not?
No,
I didn't hear what you said. I'm asking you. So the gases are going up. What will stop that from going up? If it's warm and it's rising,
Gravity.
what will reverse that other than the temperature cooling down?
An additional force, such as gravity.
That's what I'm asking you. How does gravity affect the gases?
That's an entirely different question.
What's a different question?
This attempt that you misconstrue about what causes gravity and the actual observation of gravity.
I'm not asking what causes gravity. You're saying gravity.
Well, then you go ahead and why don't you engage with some people who are doing experiments under quantum mechanics to try and figure out if there is something that causes gravity, and if so, what it is.
I'm interested in what causes gravity. Yeah, that's what causes
Well,
gravity.
then you can abandon any of these nonsense questions aimed at trying to figure out what causes gravity.
I'm trying to find out about what causes acceleration, not gravity.
That's the same thing as trying to find out what causes gravity, which you just stated you're not interested in.
Not the cause of gravity, the cause of the acceleration.
Gravity is the acceleration, chemo.
Yes, gravity is the force that is actually equivalent to what you're describing as the acceleration.
Which gravity
and
are you
just
referring
stated
to?
you're not
Doesn't matter,
interested
chemo,
in
they're all
finding
the
the
same.
cause,
Stop with
so
this.
you can abandon any of these questions aimed at that.
Stop
No,
with
I'm
the
not interested
stupid
in
witch
the
gravity,
cause of
chemo.
gravity. We're looking
Stop
for
with the stupid witch gravity,
looking for the
chemo. You know it's the
cause
same.
of the acceleration.
Newtonian and Einsteinian are the same
So which
thing.
gravity are you referring to?
Doesn't matter, chemo. They're the same.
No, they're not.
Yes, they are. They're exactly the same thing. You can derive the
Yeah, Baz, can you hear
Newtonian
me or you can't
equation
hear me?
from the Einsteinian
Which
equation.
gravity
Did
are
you have
you
ignored me,
referring to
chemo?
for
Chemo,
this
have you muted me
acceleration?
or what? Chemo, have you muted me or what?
They're not the same.
They're exactly
You're
the
saying there's an
same.
acceleration, but you're saying gravity. Now I'm asking you which gravity.
Doesn't matter, chemo. Einsteinian gravity and Newtonian gravity are the same damn thing.
Bowers, are you not there?
They give the same results,
The gravity
especially on
locally
Earth.
here on Earth is equivalently the same under what's described, and it is a description, a clarification, so to speak, of gravity under classical physics, commonly referred to as Newtonian physics, or relativistic physics, commonly referred to as Einsteinian physics.
Okay, so what's the scientific experiment for the bending of space-time?
See, now you're getting into what causes gravity,
No, I
which
didn't
you
say
already
that. I said,
previously stated you're not interested in.
I'm not interested in the cause. We're asking you for the scientific experiment to validate what causes the acceleration.
Yeah, chemo.
See,
That's
what
exactly what you're
causes the
asking for. The
acceleration?
cause.
That's asking for that.
Yeah, that's what I did say.
Which
I'm not interested
there
in
is
the cause of
nothing
gravity.
as of yet to actually establish that there is a cause for gravity, or if there is, what it is.
Yeah, just the acceleration. What causes it? You said gravity causes the acceleration.
No, that's blatantly incorrect, because what you're describing as gravity and the acceleration due to gravity is one and the same.
So we have an acceleration, and it's caused by we have this effect, which is acceleration. Things.
What was
falling.
previously stated about the cause for gravity?
Not the cause of gravity, the acceleration.
Same
And
thing,
in
chemo.
context, that's one and the same.
What? Gravity is the acceleration, and gravity is the cause.
In the context that is being applied, yes.
Gravity caused gravity.
Chemo.
Are you saying
shut
that?
the fuck
Do
up,
you want
you
to
moron.
explore that?
Well, I'm asking you, are you saying the cause and the effect are the same thing?
The acceleration
No,
due to gravity.
I did not say that. I already
Come
stated
on.
clearly what it was.
Okay, so we have this acceleration, the gases, downward bias. You said that's caused by a force.
No, that's incorrect to say it that way because I described it as being one and the same. The acceleration and the actual downward bias and gravity are the exact same thing, an observed phenomenon.
Gravity is the effect and gravity is the cause.
That's what you're trying to say, and that's blatantly incorrect.
Okay, so what is the effect?
Chemo, you're not this dead.
That's
Stop
the same
working in
thing
circles.
as asking for the cause, which you just previously stated you weren't interested in.
No. What is the downward bias? What's that effect called? The downward bias.
The downward bias is actually called gravity. That's not the same as actually looking for the effect of it.
Chemo, stop being so fucking pedantic, Chemo. You know the answer here. Stop being so fucking pedantic.
So the acceleration is supposed to be the constant.
And you go right back to being pedantic. Fucking
So, gravity is describing the cause and effect.
No, that's incorrect to say it that way. Gravity is the observed phenomenon of the acceleration of
Gravity is
the actual
definitely
downward bias.
No, gravity is definitely describing the cause and the effect. It's
You are
a
idiots,
causal
too.
relationship.
No,
that's
fuck
incorrect.
What do you mean? What are you talking about?
These guys are dead. These guys are screwing themselves up. Chemo's doing nothing but doing fucking pedantic bullshit. Stop it.
It does.
Who are these guys? I don't think you realize who's talking.
Gravity
Chemo's
is the
Go ahead,
gravity is
Phil, go ahead.
describing the cause of an effect. Gravity is describing the cause and effect relationship. It's not. Yeah, I don't understand how you can disagree with that.
Because it's an incorrect description as compared to the actual description of gravity, mass attracting mass. The
That is
phenomenon.
gravity. That is gravity. That is the definition of gravity: is mass attracting mass.
Yes, that's the actual description. This other description, trying to claim that it's cause and effect as one and the same, is incorrect.
No, what I'm saying is gravity. What we term as gravity is the cause and effect relationship. Right? Gravity is the combination of mass causing a bending of space-time and simultaneously how masses move through bent space-time.
No,
It's
because
describing
gravity is
them
describing the
simultaneously.
relationship between the masses. It's not the actual cause for that relationship.
Does the mass distribution cause a curvature of space-time?
It's describing the relationship of the mass distribution.
Okay. Is that the same as saying it's a cause? Without
No,
mass
it's
distribution,
not really,
is there
because
a
it's not actually describing what causes gravity.
Well, this is an argument of there could be an effect that is in between gravity and the curvature of space-time. The current description says mass distribution is the cause, because if it's not there, right, then there is no curvature of space-time.
You're confusing the theory of gravity with saying gravity. Gravity is just mass attracting mass. The theory of gravity is the whole space-time shit. The
Right, well, then
theory,
maybe
the
we should
theory
be a
of
little more
gravity, because the theory of gravity is explaining why gravity happens, why mass attracts mass, but just gravity is mass attracting mass.
Well, that seems really stupid, right? You should say like the force of gravity or some other thing, which is why we say the force of gravity, not gravity. Because then when you say the force of gravity, you're saying, okay, the effect, which is aka the force.
No, that's getting back to this thing of cause and effect, which is not what's thing. And as for it being stupid, well, it's actually useful to describe so that we can use it for prediction of future events and how they actually occur.
I'm not arguing that gravity doesn't exist, by the way. I'm just trying to make people be more precise about what they mean. So when you say gravity, right, it's confusing because what you mean to say is the force of gravity. Because the force of gravity is the effect, right? And the cause, right, is the mass. But gravity as a theory is a combination of how mass creates a force. So if you want to be very precise, you should say the force of gravity, not just gravity.
Well, in the context, they're actually being used colloquially interchangeable. But yes, what you are trying to actually get at is the cause for gravity, which is currently not listed or defined or even known.
Force of gravity is mass bending the space-time.
Yeah, I think that's a perfectly fair description. I think it's perfectly fair to say mass is the cause. Like, we don't know why gravity exists, right? We don't know why mass causes.
That's what they're getting at when they say
you
cause.
just explained to him, Phil. Without the mass, then the fabric cannot bend. That's how. I mean, again, if you're talking philosophically, why did the mass get so large? That's a different question. But mass is, in your world, the cause of these.
Yeah, why mass does that is not known, because that touches on like the fundamental mechanism, quantum mechanically, why mass causes. Because we know how mass comes about, but we don't know how mass, why mass creates the bending of space-time. We just know that it does.
And why does bowling ball bend the trampoline?
Well, the trampoline, there's a force acting on the trampoline, which is causing it to stretch. That's
bending the fabric around it. So if the fabric that we live in is an actual physical fabric, then of course the mass would bend it.
Well, not necessarily. I mean, we observe it to be true.
Fabric and space are real physical things. Bent, warped.
Yeah. Yeah, it's real.
So there you go. In your world, that's how it works.
Yeah, no one's disagreeing with that.
That is the current best explanation of it. That is not the theory of gravity. That's the current best theory of gravity. But if you want to talk about just gravity, it's mass attracting mass.
Fact is observed.
Yeah. Gravity is observed. Theory of gravity is experimented with and tried and theorized about.
I mean, I think it's a fantastic theory that Einstein came up with. It would make sense if we were on a ball. Space. But that's just the problem. It's just a mathematical equation based on the Earth globe.
Actually, gravity needs the globe. You don't need the Earth for gravity.
Yeah, you don't need it to be a globe for gravity. You don't even need a globe for space-time curvature gravity, Chemo.
No, you need large bodies of mass.
No, you don't.
To warp space-time around. Yes, to create these gravity wows, how are you going to have that in just fabric?
Matter. You need that matter.
You could have energy of any sort.
Yeah,
you don't need mass. You just need energy.
You literally don't need matter at all. All you need is either, essentially, to get space-time curvature gradient or gravity. All you need is a time gradient. That's all you need.
That's theoretical mumbo jumbo.
Well, it describes our reality pretty well, so it's fine. You can call it theory all you want, but there's a reason why it's called a theory.
You guys are talking about a medium in a place you've never been to or experienced.
Yeah, we've never been in reality. Merle, we've never been in reality.
You've never been off the Earth. No, you haven't.
But Earth isn't in reality, Merle?
No, but
so
what you were talking about...
So can we not test reality while on Earth?
What you were talking about just then wasn't connected to reality. You were talking about gravity wells and that it doesn't matter if there's mass there or not.
Well, we can see time dilation happen on Earth. We don't need to go to space for that, Merle.
Mm-hmm. We can measure the redshifting of light, which is caused by the bending of space-time on Earth without going into space.
We can do experiments about this on Earth, Merle, so your argument is null and void.
Except Einstein, because we forced them to. And now, once they're, it's
No, it's not you forcing us to. It's actually reality.
No, you guys are struggling to either go with Newton or...
No, nobody struggles with that, Only you struggle with that.
You're...
Yeah.
And it's understandable.
It makes more sense
here on
to
Earth.
go with Einsteinian.
Emo, you seem to misunderstand. Here on Earth, Newtonian and Einsteinian gravity have the same result, exact same result, different explanations why. That is the only difference. You can use Newton's gravity and get the exact same result as Einsteinian gravity. Here on Earth, zero difference in the result.
Up to a certain precision. Up to a certain precision, right?
Yeah, and Einstein explained a lot more. Galaxies, cosmos.
So, Chemo, do you want to take a guess at where exactly do you input the information of the warpage of space-time into the classical description of gravity?
Look, remember, now we just get into theoretics. You who said, we can demonstrate this force. Now we're learning it's not a force.
Hold on. Acceleration, Chemo, not a force.
And
real cool.
Well, if you actually... Oh, go ahead. Sorry. Go ahead.
I was going to say, Chemo, do you have any, like, boxed products in your kitchen? Or just anything with like, to cook with?
It's not about me.
Yeah, no, it is, because this is an easy explanation for you. I'll raise an analogy on the differences between the supposed gravities.
Right.
Just gravity, like a tomato sauce or, a soup can, something, man. Just something, anything. On the label, it'll say, like this one I got right here, I got Alfredo. Obviously, my can's name isn't Alfredo, so I assume it's Alfredo sauce. But if I turn around and go to the back, where it says ingredients, it gives me a really long list, unfortunately, of what makes up Alfredo. It's the same difference. You got one tells you what it is, the other one tells you even more of what it is. Get it?
Mm-hmm.
It doesn't stop it from being Alfredo sauce just because if I just read the back of it, right? I can still make spaghetti.
Right.
So you're bitching over the ingredients right now for some weird reason.
No, we're just trying to make sure current science.
No, you're just being a sea lion. You know all these answers. You've been told a bazillion times, and you still come back with the same old script, Chemo. Don't you ever get tired of the script, Chemo?
Not sure.
Chemo, do you ever get tired of the script?
In a vacuum.
Actually, they've done it in a vacuum, Chemo. You've been shown it. You actually showed the pictures the other day. Live video cam. Didn't Biojule do it? You've been given the papers for at least 2 different experiments. And you always reject it.
Chemo is selectively blind, okay?
Oh, he's selectively amnesia, too.
That was just his trial run, nothing to get...
it was good enough, Chemo. It showed mass attracting mass inside a vacuum on film, like you asked, on video.
This time.
Just like you asked, Chemo.
And he's going to have the camera focused on mass attracting.
You're just the same, Chemo.
Yes,
you won't see the attractive force, Chemo. You won't see the attractive force.
To see the what it'll become is to see the tentacles actually cause it to move. You know, to see little unicorns come out of the mass and push on the masses.
That mass should be hitting the glass, touching the larger mass, like wanting to touch it.
No, they can't touch. There is a glass there, right?
There's also a torsion.
The glass,
there's torsion.
Like it wants to go through the glass. Obviously, it can't. It wants to touch the larger mass. That's what we want to see.
People, that's not going to happen.
You only ask
if mass attracts mass.
It won't. No. It's got a torsion.
You only ask to show attraction. Now they need to touch.
No. You've got to show the mass.
Yes.
Like I said.
No, you said movement. You said movement. I remember your contract that you didn't sign, but you had this contract that said movement.
So you can hold a piece of string, have a weight in the middle and a weight on the bottom, and you can swing the middle weight without swinging the bottom weight. See? And that...
No, you can't. It's on a roll.
Well, I want to see that.
It's a rigid roll. It's not
it's like a skipping rope, where you just don't spin the middle part.
You said... let's go with what you just said. I want to see you do that if you don't mind.
You know what I mean. Stop being silly. So we know we've all done that. Where you spin a rope and you can spin the middle part of the rope and have the bottom part dangling.
It's not a rope.
No, I've never seen anyone do that. Can you please show that?
Yeah. Stop being silly. So
Ever.
like I said, so in that gyro thing,
It's
in
the
that
weirdest shit in the world
vacuum
to see.
thing, that's essentially what he had. He had the wire spinning around, affecting the torsion balance, but not the mass wasn't moving.
The wire is the torsion balance.
Yeah, so all of that was being affected, but not the mass.
Yeah, well,
it sounds like, you know,
what?
let me ask you what you're...
Was that the mirror connected to the road, Chemo?
To the wire.
To the road. There was no wire.
Show us
It's a
properly.
road.
He wouldn't zoom in on the
It's a
cabbage
road,
itself. He wouldn't.
not a wire.
Wouldn't
There's
show
only
us.
wire at the top. Above the road, there is a
Wouldn't
wire.
see it properly. Wouldn't move the camera on the actual masses so we could see
You already denied this, Chemo. You said you're not going to accept it unless it touches the glass. That's not going to happen. The design of the experiment is no way in keeping with that happening. Therefore, you are not going to ever accept the results.
That's because mass does not
Therefore,
attract
Bio
mass.
shouldn't take any more effort to try and prove it to you.
Yeah, I don't see why he's doing it because, like I said, we're
Well,
not going to see
sometimes
mass
it would.
coming together with another mass. Like when we
No.
jump, we come back down to the earth and we connect. So we want to see that mass jump
Chemo,
and
how-
come
how
back
would-
and connect the larger mass.
So now you want him to have a bigger vacuum chamber, right?
Like I
Where
said,
he
all you
can
got
put
to do
the
is have
two
that
masses inside.
smaller pendulum.
No, Chemo. You said you will accept it.
If
There
we
is a
see the
movement,
mass
and
attracting
there was
mass,
a
yes.
movement. Then there was a movement.
I mean, that test was so flawed. The table was all over the place when he
Doesn't matter,
lifted up
the
the
table.
weights there. Table was moving back and
Doesn't
forth, back
matter.
and forth, knocking the vacuum.
No.
I mean, it was
No,
his
it
first
wasn't.
time, so we can't really, you know.
No, it wasn't. It let it come to rest.
No. He said it would take days, and he did it within a couple of hours. Come on.
Yep.
Come on.
He didn't do the math on it.
We didn't let it settle properly, so of course it's going to dangle and
It's
swing and
It's
later.
not settled. Yeah, it was evident in the video it's settled.
Like I said, we didn't.
No. How do you say it didn't settle?
We didn't see the
Did you
observation,
stop
Moya.
moving? I saw it stop moving.
You're not going to deceive us with a couple of lasers.
Okay, how do you claim that it didn't stop moving? It stopped moving. I saw no motion. What are you?
What we need to see is actually look at the thing to see if it's moving or not.
Yes, we did. Now, what are you going to do?
He showed lasers. We didn't get to look at the mass.
The laser was attached
Why
to the
you think
mass.
the laser was moving,
Yes,
Chemo?
Yeah, I'm not buying that. I'm not buying that. That's
Why
not
was the laser?
I'm not
Why
about
was
to
the
become a
laser
bored
moving,
earther
Chemo?
based on lasers.
No,
Don't
the
be silly.
laser were reflecting from the mirror.
They were
It was a
reflecting
Oh yeah,
from the
hey
mirror
guys,
back to
guess
the
what?
masses,
Saw a
Chemo.
couple of
Which
lasers. Now the Earth is a ball.
chemo, which the masses
Which
was
were
also,
attracted
were
to the
also
masses.
attached
But
to.
if I
So
saw a
they
couple of
all
objects
had to move
miraculously
together.
moving towards one, I'd be like, "Whoa,
How
that
do you move the
is
road if the masses are
that's a
not
serious
moving?
observed phenomena here that I'm gonna have to take all
How-
about." Right,
how
CB,
do you move the
hey
road,
guys, check out these lasers. You know what they'd say
You
to
know-
me?
Chemo, how do you move the road if the masses are not moving? When they are all attached to the road.
Hey Merle, guess what? I'm a glober now. Why? Oh, because I saw a couple of lasers bouncing on a piece of paper.
They were tacked to the mass, so they did the exact
Sounds like
thing
a
you
type of
wanted.
subject, doesn't it? So what is that? What's your kind of disdain for the lasers?
Let's
I'm
think
just
about
curious.
it. Let's say we tell somebody that you became a glober because you saw lasers.
Well, Chemo, they got people who
Chemo.
turn to be a glober for other reasons.
You know,
Why wouldn't laser be
a
one?
lot of flat earthers say, "Oh, I'm a flat earther because of the Fe core laser experiments." So they're flat earthers because of a laser. Are you gonna call them just as stupid?
Well, you're not taking any distance measurements, are you? Just taking what you think is.
What
change
distance
the
measurements are you
subject.
talking about?
So, for example, when a taboo conspiracy fired his laser 20 miles down a straight road with no curvature.
Was it straight?
Yeah, it was super straight. Straightest road in the straightest road in the world, actually.
It has curvature. It has
And it was
undulation.
Mikey Smith, and it goes downhill that road.
Yeah, but it's still the
down and
straightest
up in all
road.
directions.
No obstruction from top to bottom.
No,
do you know?
straight means it doesn't bend from left to right. It doesn't mean
Yeah.
that it doesn't have any hills in it.
I should have brought that up last night, actually, when he asked me about the horizons. How do you have a geometric? How do you have a apparent horizon without, the curve? But That road.
How do you have any horizon on a flat Earth? Just curious.
Well, that road, that straight road, okay, the longest straightest road in the world, Guinness Book of Records and stuff. You look out 3 miles down that road, and you can't see beyond it, with no physical.
As already covered by the angle of declination. So you're gonna have to find something new.
No geometric horizon to give their apparent horizons. You can have apparent horizon without geometric horizon.
You're saying you're up a hill. It isn't a straight. It isn't straight in the sense that it's flat. It's down a hill.
Yeah. So when you're looking down, you can't see the entire way. You say on a flat plane, you should be able to see the entire way. And we say no, you can only see as far to the horizon. Same as that on that road, there is a horizon, and you can only see as far as not the entire road.
What is the horizon?
How could he see the laser then?
Because it was at night, no obstruction.
So what's obstructing it?
Yeah, there's an obstruction in the day, but not at night. What are you saying?
You see, now we're getting there. All right.
No, we're asking you that question.
We're getting
Chemo.
closer to understanding, right? So
An obstruction. There is no recorded obstruction. You have no reason to believe there is an obstruction.
But this is good. So they fired it 20 miles. If you're 6 foot, the horizon is around 3 miles. That is
if you're on flat ground, but you aren't on flat ground.
Not flat ground if you have no obstruction in between. You say you can see
it's
to
a hill. It doesn't matter if it's a bumpy hill or a smooth hill. It's a hill.
You say you can see the stars, right? Because you can see as far as you like. But now we should, according to your logic, see all the way down to the top or to the bottom of that road.
Okay.
Well, that depends, doesn't it?
On what?
On a variety of things.
Oh, interesting. Like what?
Well, it could. If there's fog in the atmosphere, we wouldn't be able to see it, right?
Good. That's one. What else? Why can't we see the entire?
How is this relevant to the stars?
Because we're showing you, or I'm showing you at least, that you have a straight road, no obstruction between you and the other observer, but you still can't see the entire way. With no obstruction.
Yeah.
No, that would be with an obstruction. You're
fog is
obstructed by fog. That's an obstruction.
Yeah.
If what, sorry?
What I described was fog. That is an obstruction.
No, I know. I'm just saying though that we are told that you should be able to see the entire way, and that you've just said, well, fog.
The entire way to what?
On a flat Earth, you can say fog stops you from seeing the entire way from one end to another.
You could say that, yeah. However, it should allow you to see certain distances.
Yeah, but on this day, there was no fog.
And you should have a change in what you can see. And you would hope for like really clear days where you could see like a really long way, right?
This was a really clear day. It was a nice sunny day. He was in his shorts, riding his bike. And you cannot see the entire way from one end to another. According to you guys, you should be able to. No obstruction. No physical obstruction. Straight slope.
What is your idea? Because it sounds like you have an idea of what was obstructing it.
No, I'm asking you guys. Why can't he see the entire way?
You can hear it in your.
There is an obstruction, Chemo.
Well, hold on. He's got this weird lilt to his question. So, Chemo, what is it?
No, I'm not making any claims. I'm saying, according to you guys, we should see the entire way if there was no physical obstruction. There's no physical obstruction in this world record straightest measured road. Been validated, measured, all that kind of stuff. So if we have no obstruction, why can't we see? But what you should understand and must understand.
Why do you say there is no obstruction?
What, there is an obstruction. What's the obstruction?
Earth?
Straight road. What's the obstruction?
Earth?
Well, by your definition, it's not straight. If it's got hills, it's not straight.
It's the straightest road in the world.
No, that may be the case, but it doesn't say that it's straight.
Oh my god!
Straight test. Straight
it says
test.
the straightest
Straight
road
test.
in the
Straight
world.
test does not mean absolutely straight. It means
Oh
it is
my
the most straight.
Right. It's been measured as the straightest road.
Less than perfectly straight.
Hold on, Chemo, you've acknowledged that it's downhill, right?
Well, I mean, they say that. I don't know if they got the actual right road, but whatever the case, the point is that you have
either
no
they
obstruction.
know that it's straight, either they know
I
it's
got the
straight,
right
or they
road.
don't.
It's easily spotted on Google Earth. You can check the elevations yourself.
Oh
You can
no,
look at
yeah,
the
but
elevation
again,
profile.
I'm not doubting you, so that's why I'm going with it.
Even what's his name? Who posted that video?
Taboo.
Taboo. Even he admitted it in his comments.
Yeah, that's fine. That's fine. That's fine. Like I said, that's why I'm not arguing that.
After I corrected him,
You can work with that. It's not a point. Not a problem, because we still have no obstruction between one end and the other.
So why can't you see?
And the reason why we know over 20 miles, can't see 20 miles down that road in the day, but at night we can fire a laser one end, not one end of the road to the other, but over that 20 miles we can fire the laser.
Why not from one end to the other?
Well, how come?
Probably could. They didn't test that far. A lot of money
So then what?
would have cost a lot of petrol to drive 100 and something miles, right? Duh.
So then, what's the limitation during the day as opposed to at night? Let's hear that.
But again, I don't know what's going on. I don't know why they couldn't see the entire way. There was no obstruction, but they couldn't see the entire way. At night, they can fire a laser and see more than 20 miles.
He's slurping again.
I know. Lasers work during the day too, so what's your point?
Yeah, but just like the stars, you'll get more visibility at night.
That really doesn't change the visibility at the end
really
of
does.
the laser.
It really does. Because there's light pollution. Yeah?
Yeah, but you can still see the laser during the day.
Yeah.
You still see it, but not as far and as well. You would struggle. You would squint. I mean, even at night, it's a struggle to see it. Like, can you see me now? Can you see me now?
Your camera doesn't work that. Have you ever shown a laser at your camera before?
Well, I've closed my eyelid and put like the laser. You know, and it's super bright.
No.
Like you got your eye light blue or red or green or whatever laser you look.
Okay. It just means
that
you've never done it. That's fine.
That road.
If you've never done it.
That road has an apparent horizon without a geometric horizon. How is that possible?
You tell us. You're the one who seems to have the idea.
Well, I mean, again, we've got it measured. Guinness Book of World Records and Wikipedia, everything that you need to make sure it's been surveyed correctly. So it's not like we're just making it up. The biker went down there. The ball earther biker went to that road specifically because he said this is the straightest road. It's been surveyed. We can do great measurements here. And he came up with a ball, obviously. But the idea is he didn't know that at night you could fire a laser down that road 20 miles. And there's no obstruction.
So then what was the obstruction then?
In the day?
Yeah, if there's no obstruction whatsoever,
It just
then what
proves what we were telling you guys about how the ground rises up and the sky lowers and converges and gives the appearance of...
dude, perspective works at night too, so that doesn't work.
No, I'm saying that's what's happening in the day on this road. That the ground is rising, the earth is coming down. Not the earth, the sky is coming down, appearing to... They're converging, appearing to meet.
Perspective still works at night.
Because look, if we were to do a side-by-side, night and day, along that road, we would fire the laser 20 miles.
So you're kind of funding muting, Gino.
Pardon?
So you're kind of funding muting. Somebody else was talking there for a second. You kind of just continue.
Trying to throw it. I mean, he's not even a ball earther.
It doesn't matter. You blathered over him.
Well, I wasn't trying to. I thought we were going back and forth.
Well, you tell when somebody else is talking, you hear words coming out of their mouth.
Yeah, but I'm answering his question, and he's asking me another question straight away afterwards. Yeah? A little bit hard work. But, yeah, I mean, he can't answer the simple questions that fire a laser on one side, daytime, won't see it after so long, nighttime, you like that are a problem. I didn't even bring up half of those things in the argument with him. To prove the
What is that? Shaky, what is that?
What is what?
That's a laser pointed at the camera.
Oh, laser at a camera, okay.
Okay, what is that supposed to show?
How you see a laser that's pointed to the camera.
I think what's interesting is even when it's not pointed at the camera, stray laser still
So
hits.
Moya, what's causing that horizon?
You can tell I was speaking when I was just speaking there, right? I think so.
If there's no...
So what happens, Chike, if you're not aiming directly at the camera? Still stray laser light hits it, doesn't it?
Not so much.
Well, tip it a little bit away. I mean, you can see the laser at almost any angle. Not the main beam won't hit you, but let me get my laser and do that.
Actually, it's partial reflection from water.
Super chat, Jam.
Ooh, super chat. Where is my silly thing? Can't find it.
Find it.
I'm going there now.
So Merle, where's Merle?
I knew it'd be JD. Thank you very much for the super chat, JD. He says, less FE bias in your muting, please. I think he means you, Chemo.
Yeah, sorry about that.
Who did you mute? NASA.
I didn't mute him. Done about
Oh, right.
Bearded Dragon when I was talking.
Oh, right.
I don't think I didn't mute NASA, by the way. Is he mute?
No.
Not mute.
No, I'm here. You just turn my volume down because
I didn't turn your volume. You're just being very rude. As I'm trying
rude.
to
Telling you that
ask
you're full of
about
shit like
some questions.
You're just
See
sea
that
lining
I
once
was
again,
tangling
Chemo.
him up.
No, you weren't. You were just sea lining, saying
You're
that
there to save him.
plain pedantic bullshit, playing your little word games.
No, you absolutely didn't, Chemo. You misunderstood it, even though it was clearly described multiple times.
Yeah, you just had to be educated by Phil on how and what gravity should be placed.
Actually, he just reiterated the same things I was in a different format.
Oh, right.
But again, you didn't understand it, and you still fail to understand it. I apologize for you, Chemo, failing to understand it.
He understands it. He's just ignoring
Started
it.
this by saying you can weigh the air outside of a container.
You can.
It has weight.
Yes.
Right? So
okay, that's a blatant lie, and that was already previously covered. That is not at all what I stated, and you know it.
Yeah, if you didn't make this wild claim, then we wouldn't be in this. You wouldn't be getting
That's
the help.
because I didn't make that wild claim, and you know it, and that was already previously addressed.
Right, you
Try
said
again,
this.
Chemo.
The air has weight outside the container.
Yes, it does. That's what barometric pressure is.
Sure. Why didn't you cool down a bit, Junior? Chemo had him in the corner. Settle down.
It's exactly what barometric pressure is, Chemo. The weight of the air above you.
Well, he's not going to let you talk, cowbells. And you're just letting him gate.
That was actually another
White
example.
Knight for
That's
you.
not the example that I actually used, but it's still the same principle.
Weight outside of a container. How are you weighing this?
Well, with a barometer.
You were just provided yet another example that actually substantiates the principle that air does have weight outside of a container.
Are you just copying one another?
Not exactly, because he's providing a different method for
He didn't say
establishing
he
the
can
same
weigh the
principle.
weight of the
But
air outside the
you
container.
still have not yet provided anything to support what you present as it automatically doesn't have weight outside of a container.
I've just told you, conspiracy cats. Without the container, there is no pressure.
That's a claim.
Yeah, wrong.
You haven't provided anything of an observation or actually a reasonable conclusion or description or line of reasoning for that.
Why would conspiracy cats lie then? Why don't you trust them? Why don't you believe
Misquoting
that?
conspiracy cats once again. That's your other fun thing to do, is just to misquote people.
Why don't you believe what conspiracy cat says then? What's the problem? Why have I got to get more than
I
what
don't
he says?
believe your interpretation because you are a known liar.
So you interpret that different. Without the container, there is no pressure. To you, there's a different interpretation.
Actually, there's observations that actually show that to not be correct conclusion.
But what's the interpretation then? How can you have pressure without the container?
Look, Timo, you take a
You're
barometer.
blatantly just ignoring that you've been provided two different methods with different observations that show that not to be a valid line of logic or reasoning.
No, you haven't said any of that. Other people have said stuff. What do you say?
Now that's just a blatant lie because I already previously stated observations and a different method for actually substantiating the principle that air does have weight outside of a container.
By observing the air, you detect weight.
What do you think weight is, Chemo?
Which you actually did agree to because you actually went into the acceleration, and the acceleration is independent of the container.
That's what I'm asking you. This acceleration, where did it get it from? How can it just start moving?
And it was actually described by multiple people that it's just a description that there is acceleration there. And you want to try and do this malformed need of having an explanation of the cause or the why of that, which was already previously described. We don't have that. That it isn't there.
So you don't know why. You haven't got the cause and effect.
That's independent of that it's actually there.
Well, it's not, because it could be something else.
Then go ahead and provide observations or something that is valid as a conclusion or a line of reasoning for that.
Yeah, relative density.
That's been disproven by the actual observations of putting relative density horizontally and achieving a different effect of it being downward.
How have you disproven this relative density?
It is not dependent upon relative density. And you know this.
Proven that
has
it's
no
relative
force.
density.
Relative density has no units or direction, Chemo. It cannot
What
explain
experiment
anything.
do you have to combat the relative density
How
experiment?
does
Cavendish.
Kimo, how does relative density cause a pressure gradient?
How does it what? What pressure gradient?
How the pressure gradient that I have
Pressure
here in my
gradient
room.
exists.
In my
What
room.
pressure gradient?
In
What
my
do you mean,
room,
what
there is
pressure
a pressure
gradient?
gradient. Kimo.
I can't hear too.
What do you mean, what pressure gradient, you moron? You can say there's no pressure gradient?
Yeah.
Yeah, stop affirming the consequences, Mikey.
No, Chemo. Is there a pressure gradient?
When you invoke pressure, that's the very thing we're trying to ask, where does it come
Is
from?
there a pressure gradient, Chemo?
Now, if we can't figure out where the acceleration comes from, you have no pressure
We know where the
gradient.
acceleration comes from, Chemo. It's called gravity.
That's incorrect, Guillermo, because we have observations, actual measurements of there being a pressure gradient. And that's independent of this thing that you want to try to run to of forcing that there needs to be a cause and that cause shown. There's actual measurements of it, which is actual validation that it exists.
He asserts that it's temperature.
Well,
It can
again,
be temperature
cowbells, you're just
because I
making wild, outrageous claims without being able to back up
Timo,
anything.
so how do you explain pressure gradient in homogeneous temperature and how would you say composition of air? How do you explain pressure?
There is no
Again,
containment.
you're talking about a lot of things.
How does relative density here cause a pressure gradient?
How can you have gas pressure without it being contained. Your container is gravity. Gravity has no effect on gases. It's simple.
What?
Remove gravity.
What?
Pulling down gas.
Why does gravity have no effect on gases, you idiot?
I asked a simple question.
What do you mean? What? It's not an idiotic thing to say.
Yes, it is an idiotic thing to say. Gas has mass. Gas has mass, you moron. You take gas.